Hello, everyone. Thanks for joining this session. If you are here at this talk, just let me know in the chat so I know everything is working. Thanks for the confirmation, Pep. I'm gonna share my screen now so we can start the talk. Just a second. Yeah, hopefully everyone can see my presentation now. So today I'm gonna talk a little bit about OS3. And my objective is to try to describe the technology, what's behind the technology, and understand how can we use OS3 on an embedded Linux device. And hopefully, I'm planning some hands-on here, so hopefully everything will work as planned. So during the presentation, I will open a terminal and do some hands-on here. Before I start the presentation, a little bit about myself. So my name is Sergio Prado. I've been working with embedded for several years, 25 plus years right now. I've been working with my company for 10 plus years here in Brazil. So I'm located in São Paulo, Brazil. And here I'm doing several training consulting on local companies here. For the last year or so, I've been working at Toradex. I'm leading the team that is developing Horizon Core. Horizon Core is an embedded Linux distribution for Toradex modules that uses OS3. So that's one of the reasons I'm doing this talk, to share a little bit about what I've learned using OS3 on embedded Linux devices. I'm also an open source contributor, so I have a few contributions on a few projects like Buildhoot, Yocto, the kernel. I sometimes write some technical posts at my blog, embeddedbit.org, and those are also my network links if you want to connect with me, LinkedIn and Twitter. Let's start the talk. So we're gonna basically cover here 4 topics. First, what is OS3? Then we're gonna discuss a little bit about how can we boot OS3 on an embedded Linux device. How does it work? Because as we're gonna see, OS3 is basically content addressable management system. So it's kind of like Git. How can we use that on an embedded device as the root file system? We're going to also discuss a little bit about how can we build an embedded Linux system with OS3. And in the end, we're going to talk a little bit about how can we use it as a remote update system. That's one of the big advantages of an OS3 based system. First, what is OS3? So OS3, that is also known as libostree. It provides a kind of a Git-like model to boot complete file systems. So with OS3, you can basically have a repository with your complete file system, and you can version control it, so you can commit versions of your file system in this repository, and you can check out versions of this file system. So every time you have a new version of a file system, you just commit to this repo, and then you can check out at any time. That's basically how Git works, right? So it's pretty much like the same concepts. But if we look a little bit internally of how OS3 works and some of its design decisions, we're going to see that there are some differences when we compare to Git. But in general, it's pretty much similar. So it's OS3 is a content addressed object store. So you store objects, that's the files. They are checksummed. So in the repository, you have the files, and the name of the files are basically the checksum of the content of the files. And you can restore this at any time. So as I mentioned, you can commit to the repository, you can check out from the repository. But in other sense, it's a little bit different because, for example, it uses SHA-2556. When you check out a version of the repository, you're gonna basically create hard links. That's different from how Git works, right? When you check out a version, basically Git will create a working directory with a version. It will generate for you that snapshot of your repository that you're requesting with the checkout operation. But with OS3, it will create hard links to the objects in the repository. And there is a reason for that we're going to discuss here in this presentation. In both Git and OS3, we can have like remotes. So we can pull from remotes, pull the objects from remotes. But in OS3, you don't have the concept of push, for example. You cannot push changes to a remote. So there's a few differences, mainly because they are for different purposes, right? And the purpose of OS3 is basically to help you manage completely bootable file system trees. That's the main idea of OS3. It is designed by Colin Waters, that's a Red Hat developer that is responsible or helps on the development of a few Fedora projects. And that's why three flavors of the Fedora distribution, they are based all on OS3, like CoreOS, Silverblue, and Fedora IoT. They're all based on OS3. And I've been using Fedora Silverblue for several months now. It's pretty much stable. It works pretty well. It's very nice. I've been using on my notebook. OS3 started on the project called GNOME Continuous. It's a kind of continuous integration project for the GNOME project. And out there we have a few distributions using OS3. For example, again, Horizon Core, the distribution that we are developing here at Toradex. There is also a few package management systems or kind of hybrid package management systems that uses OS3. rpm-ostree, they're the base for the Fedora flavors there, and Flatpak also is based on OS3. So OS3, in a nutshell, it's, as I mentioned, a Git-like content addressable object store. So you can store objects and you can recover objects from the repository. You can store individual files, or you can store full file system trees or your complete root file system. You can commit to the repo, you can check out from the repo, you have the concept of branches that in OS3 usually call refs or references, but it's basically the same thing. So a ref or a branch points to a commit that will point to an object in the OS3 repo called a G-tree that will point to other G-trees and files in the repo. The design is kind of similar. There are some differences, but similar to Git, the internal design of OS3. But it doesn't stop there. Like with Git, that's all you can do, right? But with OS3, you have more features there. So there is this concept of deploy. That it's more than a checkout. When you do a deploy in OS3, you are basically checking out a version of your root file system and preparing the system to boot from that root file system. So there is some logic needed, for example, to configure the bootloader for that. So that's why OS3 supports the bootloader specification, where you can change the bootloader files to change how the bootloader will behave, like which kernel it will use, with the kernel parameters, where is the root file system to configure the kernel parameters. So it knows, it has a logic to do all of that. And grub and U-boot, the two most common used bootloaders, is supported by OS3. You know, another nice thing is that it's completely implemented in user space, so there is no kernel space components required. You can just with a library, libostree, and command line tool, OS3, you can do almost everything. And that leads us to our first zone in this presentation. I'm gonna now open my terminal. Please let me know if you cannot see it, if the font size is good or not. Any problems, just let me know in the chat. In the first zone here, we're gonna just see how OS3 works. Let's forget for a bit about the root file system and how this is used in a real embedded Linux device. Let's just focus here on on how OS3 works, just to understand a little bit of its concepts. First of all, I'm here on my Ubuntu machine. I have OS3 installed from Ubuntu repository, and I can just open here OS3 man page. This is the command line tool that uses the libostree to manage OS3 repos. We don't have time to go over all of the different features of OS3, but we're gonna try a little bit to create a repo, add some files, commit, check out, check logs, history, all of this that we can do with Git. Let's see how it works with OS3. So the first thing I will do, I will create a repo. That's the command OS3 init, just like Git init, and I need to define the repo where I want to store the repo. So this is the command, and now I have the repo here pretty much empty, nothing in it because I just created, and now I can start populating the repository. So the first thing I will do, I will create a root file system directory with one file, hello.txt, and I'm gonna just creating this file here. Then I'm gonna add this file to the repository. I'm gonna commit this file to the repository. I have my notes here, so to not spend my time, I will just copy and paste comment and explain you how this all works. So I'm running here OS3. This is my repo. I'm gonna commit. This is the branch I want to commit. So I will create a branch called 1.0. This is the subject of my commit, and this is the files that I want to commit. Basically, I want to commit everything inside the rootfs directory. And then we have the hash of the commit. Nice. Now we can have a quick look at the repo to see how that works. So now we have some objects in the repo, right? We have basically 4 objects. We have the commit object. We can start with the ref that was created. So we can see here, if we list the ref repo, refs heads 10, we can see that the ref is basically a pointer to the commit. That's basically how also Git works. And this is the comment, and we have this object in the repository, C6, this one. So this is the commit object. There is a comment in OS3 where you can see the content of course, this is kind of binary data, right? With information about this commit. But there is a comment in OS3 that we can use, OS3 show. We can see the content of objects. So I'm gonna use this this commit. I want to see the content of the commit object, and I can see here this is the commit, and I can see information like metadata about the commit, the subject, and I can also see here this is the, where does it end? Here. So this is a pointer. This is the hash of the dir3 object. That's the root of the directory where this commit is pointing. And with this, we can see, with this object, we can see what we have inside the root directory of this commit, right? That's the object 8d. If we list again the repo, we can see the 8d is here. It's the dir3 object. And we can also have a look at the content of this object. Oops, we're missing here the first 2 characters. That's 8d. Yeah, and I need to remove the dir3. So this is the dir3 object, and it's basically pointing to our file, hello.txt. That's the only file that we have in the repo. So this is basically in a nutshell, a little bit about how internally OS3 stores the objects. We also have an object called dir-meta to store extended attributes from files. It is stored in OS3. It is stored. That's another difference from Git, right? Because in Git you cannot store like extended attributes from files, and in OS3 you can store basically everything related to to the file system, including file access, credentials, extended attributes, everything. Very nice. Let's now create a few more commits to see how the history works. I have here, I'm gonna, of course, before that, we can just remove now that we have the objects in the repository, we can just remove the root file system directory that I created with that file. I can just check out the content, right? This is the command to check out. So OS3 checkout, my repo. I want basically check out the 1.0 branch into this directory. And we have back the root file system directory with the file. So again, we can commit, we can check out, just as we can do in Git. Now I'm gonna create more commits to this repository. Oh, another thing that I forgot to mention. So when you check out, so I have just checked out right from the repo this file. When we do this, basically what OS3 do is create a hard link to the object in the repo. So both this hello.txt file and the object in the repo are the same file. They are just hard links to the same content in the disk. We can confirm that. Let's just list here. So this is our hello.txt. This is the inode. We can see that the object in the repo, it has the same inode. Let me just get the location of the object. Repo objects. Our file is this one, A5. As we can see here, the same inode, right? So it's pointing to the same content in the disk. They are both links, hard links to the file in the disk. That's how it works. So you don't since we're gonna use this on an embedded device, a limited device, we don't want to create copies of files because that would increase a lot the usage of the storage. That's one of the reasons those files are just hard links. You don't need to create a working direct with copies from the contents of the files. And that's another reason that the repository in a device, the objects, they are not compressed. Because if they were compressed, you will not be able to create the hard links, right? You will need to uncompress and create a copy of the file uncompressed in the disk. Okay, let's create a few more commits in this repo just to see how the history works. So what I've done here, I had a small root file system. I just uncompressed this root file system here. It is here, complete file system tree. I'm gonna add to the repo now, create another commit. So adding an initial root file system commit here. It will take a few seconds because now we are adding several objects, but still it's pretty much fast. And let's do another change in the repo and then create another commit, just to have some history in the repository. Now we have basically 3 commits in the repo. We can check with the command. First, we can see that we have only one reference or one branch in the repo, and then we can basically check the log or the history of this repo. So we can see that we have 3 commits in this repo. The initial commit that I created with one file, the initial file system with the complete file system tree. Oh, I forgot to change the subject of the second commit. And this is the second commit where I just added a new file, right? I added this new file to the repository. We can compare also, as we can do with Git. So what is the difference between these 2 commits? I can take this commit. We can see, let me do it here. We can see that from the second and the third commit, the only difference is that I added this file. This is also very nice, right? Because if you are doing incremental development on your file system, you can have this repo and you can compare the differences between the builds that you have done from one build to another. If every build of you're doing, you are committing to the repo. That's also a very nice feature. And you can also do all of this in the target. I'm doing all of this in the host right now, but we're going to see how that works in the target. Very nice. So we had a quick introduction to S3 and how it works. Now let's see how can we apply this on an embedded Linux device. And now that's where things got a little bit confusing, right? Because if you think about S3 is just a repo where you can check out versions of a file system. And doing that, can you all see my slides? Because I see here my camera and not my slides. Please let me know in the chat if you can see my slides or if you're seeing my camera output. So using OS3 on a real root file system, there is some work to be done, right? So if we think about, we need to ship the root file system with the OS3 repo. And we need to make sure that we have a checkout version of the root file system there. And we need to make sure that the bootloaders know what it is and how to boot all of this. So how usually that works? The implementation could be a little bit different, okay? Depends on how you want to work with OS3. But usually that's how it will work. So you will have kind of two directories, one with your boot artifacts and one with your OS3 repo, and a version checkouted. That's what we call it deployment. And then you have file system. Let me just check here the chat if you're having any problems here in our track. Again, if you are watching this talk, please let me know in the chat that you can see the slides, because again, I'm not seeing the slides in the streaming window here. I'm just seeing my video camera. Let me just quickly check here in the chat to see if everything, if there is anyone complaining. I don't think so. Okay, let's get back to the presentation. So, as I mentioned, using OS3 on an embedded Linux device is not that easy. It's going to be a little bit of work. Not that hard, but it is a little bit of work to prepare the system for it. And we're going to talk about this later. The focus now is to try to understand how a system boots with OS3. So we have basically two directories, the boot and the OS3 directory. In the boot directory, we have boot artifacts like your boot script, your kernel image, device trees, maybe device tree overlays, the hand disk, everything that you need to boot the device. And in the OS3 directory, we have basically two subdirectories. We have the repository, and we have a version of the file system checked out. That's what we call a deployment. And this is done in a specific directory, this one, OS3 deploy slash your operating system name, slash deploy slash the commit of the file system that you want to use. And the run disk script will, at boot time, bind mount this directory at your slash root directory and then switch root to it. That's how it's going to basically work. So you have your root file system as a checkout directory from the repository, and at boot time, the hand disk will bind mount this at the slash directory and switch root to it. And then you're gonna see in the end just your usual root file system. The other change that we have with OS3 is the organization of the file system. So instead, we need to really design to use OS3 in a way that every binary component of the operating system is inside the /user directory. So everything, executables, libraries, the base operating system configuration files, everything is going to be inside the user directory. We're gonna basically link like bin, sbin, lib to the user directory. That's how some distributions do today, right? Like Fedora, for example. And all of the objects there will be, all of the files there will be linked to objects in the repository, and they will be read-only. So you need to design the /user directory as a read-only directory. You should not have applications writing to this directory in any way. All of the configuration of the operating system should be inside the /etc directory. That's where you should have the configuration files. We're going to see that OS3 handles the /etc in a special way. We're going to discuss about that when we talk about what is a deployment. And the var directory, it's where you're going to store data. Everything that you generate at runtime, like logs, databases, applications data, you're going to store inside /var. And a few directories that you usually store runtime data, for example, the home directory, home links to a directory inside var. So everything that's runtime generated is going to be inside var. Operating system configuration /c, and everything else, all of the operating system components is going to be inside /user. So you need to design your system like this. If you are working with Buildroot or Yocto, you're going to design that way. This is a view of the file system layout. So we have in the left, we have the view from the storage. In the right, we have the view at runtime with the bind mount done. In the left, we have the storage. As you can see, we have the boot and OS3 directory. We have inside the boot directory a few boot artifacts, as I mentioned, like you can have their boot scripts, kernel, hard disk, device trees. And in the OS3 directory, you have two main subdirectories, the repo with your OS3 repository and the deploy directory with your deployments. That's where you check out the versions of your root file system. And we can see here the organization of the deployment directory. We have an organization per operating system. So when you deploy, you say, this is the operating system name, and you can name it. That's why you can have one repository with completely different root file system for different operating systems there. Everything inside one repository. And the directory with the content of the file system is named after the hash of the commit. And there we can see all of the complete file system tree, right? And at boot time, the hard disk would take this directory and bind mount at the /directory and switch root to it. So when the system boots, it will boot having the root file system pointing to your deployment, to the version of the file system you check it out from the repository. We're going to talk, the next slide, we're going to talk about what a deployment is, how this works. Just some more comments about this diagram. We can also see here that after the root file system is bind mounted, the /user directory is also bind mounted, but read-only. So you cannot change it. That's important because remember, inside the user, we have basically files that are hard links to the objects in the repository. You cannot change. If you change a file there, you're going to corrupt the repository. You're going to change the content of a file, and the hash of that file won't match anymore. So you cannot change it. That's why it is bind mounted read-only at boot time by your hard disk script. And the /var directory, we can see here that it is also bind mounted, and it will point to OS3 deploy var. So we can see here that if we do another deployment, what is another deployment? For example, you are updating your system. If you do that, you can see that var directory will be shared between deployments. So you will keep your runtime data between updates, right? We're going to discuss how the etc works because it is also handled in a special way. OS3 will do a merge of the content that you have in the current deployment when you do a new deployment, when you update the file system. So what is deploying a new operating system? Deploying a new operating system basically means checking out a new version of your file system. So when you do this, the first thing that will happen, and you can get back to this diagram here, it will create another directory inside this deploy directory with another directory named after the hash that you are checking out, that you are deploying. And there you're going to have a new version of your root file system. After that, it will take all of the changes that you have done in this /etc from the current deployment and will merge in the new deployment. So it will keep the changes that you have done in the operating system. And the last thing that we'll do is it will deploy the new boot artifacts like kernel if you have changes in them. If you don't have like if your new version of your file system, you didn't change the kernel or the device tree or the hand disk, it will not change the objects here. But if you change it, it will update the kernel here, the device tree, the hand disk. It will update what you have changed here. Create a new comment and you update it, and it will also update your boot script if you have one. So the deployment operation will do all of this. It will basically check out a version of a file system and also prepare the system to boot to this new version. That leads us to the second hands-on of this presentation. I'm going to be kind of quickly in this hands-on. And again, if you are watching this presentation, please let me know in the chat so I know everything is working fine. I'm going to again switch to my terminal. Hopefully you can see. So I have here a device running Horizon Core. That's Toradex distribution for Toradex modules that are based on OS3. So I'm going to log in here in my device. And we are using here OS3. We can see here with a comment called OS3 admin. So this is the version that I'm of the operating system that I'm running. This is the commit hash. We can see here the version. We can see here the branch. So we have all information about the version of the file system in the OS3 repo that I'm running right now. Let's list the block devices here. So we can see here that I have just one partition in an eMMC device. It is mounted at the sysroot directory. And if we list the sysroot directory, we can see that we have there just those two directories, right, that I mentioned, OS3 and boot. And again, in the boot directory, I have the boot artifacts. For example, here I have the kernel, the hand disk, the device trees inside this DTB directory. And in the sysroot, OS3 directory, I have the repository, the OS3 repository, and I have the deploy directory with the deployments. And here we can see the deployments, deploy and the hash. And this is my root file system that I check it out from the repo. And at the runtime, the hand disk script will bind mount this directory and switch root to it. We can see here the bind mount. Let's use here the find mount command. We can see here the bind mount. So we can see here that this directory is byte mounted at the slash directory and mounted as my root file system. We can also see that the slash user directory from there is mounted at the slash user of my root file system as read only. So I cannot change objects there. That's also important on an OS tree based design. Let's get back again to the presentation. So how can you create an embedded Linux device with OS tree? As I mentioned earlier, it's not easy. It is not also hard, but it will be a little bit of work, especially if you already have a system designed without OS tree and you have to move to OS tree. What are the main changes or main tasks to create an OS tree based system? First, you need to change the layout of your root file system. You need to comply to OS tree requirements. So one thing is you need to move everything to slash user, every operating system components. That's what distributions usually call OS tree user merge or user move. You need to move everything to slash user, and slash bin, slash sbin, slash lib, all of those directories will link to directories inside the slash user. You need to kind of design a system that is immutable. So you need to be ready to have a read-only file system. And writes will only occur on /etc and /var. That's the main objective. The other thing that you may care of is using a name service switch. That's a kind of glibc feature where you can kind of merge the contents of user and groups files. So you can have a definition of user groups for your distribution, and you can merge additional files on top of it. So in Horizon Core, we do this. I'm going to share my terminal again. So we have the default file with users. It is inside user lib pass wd. So this is the default list of users of Horizon Core. And we have also, of course, /etc/passwd with additional users. So if the final user that is using Horizon Core wants to add users to the distribution, the user cannot change /user/lib/passwd because it's read only, but the user can change this file because it is inside /etc. And if we update the distribution and update the default passwd file, if you are using the name service switch, you will be able to merge these changes to your own passwd file. So that's a very nice feature, and that's what we usually use also with OS tree. So changes in the root file system, changes in the storage, the way you generate the image. So we're gonna basically generate an image with two directories, the boot directory and the OS tree directory. You're gonna have to run a deploy operation at image generation. So you create a deploy at build time, so you can generate your image for provisioning to flash the image in the device, right? You need, of course, to have at least one deployment to boot the system. So we're gonna need to design the storage in a way that is able to boot an OS tree based system. You're gonna have to change the bootloader or the boot scripts to boot from an OS tree based system. And of course, you're gonna need logic in a hand disk to byte mount a few directories, as I mentioned, and switch root to it. So it's a little bit of work. If you are working with Open Embedded, you can do this with Meta Updater. So there is a layer that is maintained by a company called here, Meta Updater, that is basically solves the last three problems here. 2, 3, and 4. The first one you're going to have to solve by yourself. It's design of your root file system, but the last 3, almost everything is done inside MetaPdater. So you're going to basically have to set up a few variables. That is a little bit of work to port your BSP to MetaPdater to make sure it will do the right thing. But almost everything, like for example, the handdisk script, all of the logic is done. You don't need to care about this. MetaPdater also includes a few more things, like an update client called Actualizer that is able to work with a standard called Obtain for remote update system. That's an automotive standard. So it includes more things. But if you don't want to use it, that's no problem. You can just design a system with OS3 using MetaPdater without Actualizer if that's what you want. It's configurable via variables, and there is already support for a few boards like the Raspberry Pis and a few other ones. You can also try with QEMU if you want to do this. If you don't want to try in any board, just want to emulate, you can do it with QEMU. And there is some documentation. I'm not going over all of the documentation, but there is some documentation about how can you port your BSP to use OS3. Not too much work, but it's a little bit of work. It's important to read the documentation. In the end, you're going to create a few files, BB classes in the Open Embedded language, a few BB classes and configuration files to make sure MetaPdater knows how your hardware works. Very nice. The last part of this talk, remote update system. So one of the main motivations behind OS3 is to design a very reliable and efficient remote update system. My objective here is not to talk about different approaches to update a system. There are full and complete presentations about this out there. My objective is just to comment on how OS3 compares to other. First off, OS3 is not an update system. It is a kind of framework that enables you to implement a very efficient and reliable update system. And there are a few approaches, right, to update an embedded Linux device. So you can do kind of application-based or package-based update system. From one side, it's a good approach because you will not use too much like network and communication bandwidth, but from the other hand, it's not really reliable. So this is not really the right way to implement a remote update system on an embedded Linux device. One of the main features of a remote update system is the reliability. So you really need to make sure that it's reliable. It will not like break and stop your device from working. But that's the approach, for example, that desktop distributions use it, right? But usually you don't care much about reliability on a desktop distribution, right? But if you are doing updates on Ubuntu, you can stop it in the middle of an update, you may have problems, right? With when you may even boot the next time, but you may have problems trying another update. You may break dependencies and other strange errors may happen. So a package-based update system is not real good in terms of reliability. The most common approach to update an embedded device is using a partition-based. That's basically you update the full partition. For that, you can have a kind of a recovery partition to do the update. Then when you want to do update, you boot to a recovery partition or an update partition that will download and update the system right into the correct system partition. Another way to do this, that's a very common way, that's what we call A and B scheme, where you have one partition where you run your system and another partition where you want to do the update, and you keep it switch between both. So you boot in partition A when you want to do an update, you write to partition B, and then you just switch, reboot when you are done with the update, and you boot to partition B, and then the next update you're going to do in partition A, and so on. That's another way to do it. It's very reliable, but on the other hand, you're going to have to download a full partition. So you're going to probably use more network bandwidth to implement that. And also, there are some Delta-based implementations out there that could minimize this problem of I have to download the full partition to do the update, right? Now with OS 3, we can implement an update system that basically combines the best of both worlds, because OS 3 guarantees that the update is atomic. Because of the way it works, OS 3 is able to do everything in an atomic way. What that means, you will never corrupt the current file system. So everything will be done in parallel with your running system without touching your current system. It will not touch anything that is currently being used. So it will download the objects, it will do the deployment, it will do the updates in the bootloader without touching what's currently being using, without changing anything that, if it's top in the middle, it will break everything. So it is really able to do this in an atomic way. And that's very nice. And the other advantage is that it is incremental. You can send only what you want to update, only the objects that you changed in your new version of the operating system. So those are a few characteristics of using OS 3 as an update system. It is atomic, so it's very reliable. It is Delta-based. It is able to only download the changes that you have done in the operating system. You can do it on the fly while your operating system is running. The only downtime is a reboot. So when everything is done, you just reboot to boot to the new file system. You can easily do this via HTTP. I'm going to show this in the last hands-on. And there is a little bit of security there. OS 3 is not designed for security. You have to design on top of it if security is a thing for you. But there is a little bit of security. For example, you can sign commits. So you can make sure, since a commit's a hash, and if we don't have collisions in hashes, we can sign a commit and make sure that we are really downloading objects from our repository, for example. You can also sign deltas. The deltas are small packages that you send over an update operation. And you can also sign those deltas. So you can sign the commit and the content of the repository that you are pulling from a remote. So there is a few security features that, but if you want more than that, if you want like a secure channel or something like this, you're going to have to design something on top of it. And that leads us to our last hands-on. So hopefully, again, you can see my terminal. I'm gonna basically do an update here on my device. So I have here a build directory. This is a open embedded build. I have here the repository. So let me just show you the repository. This is the repository. Every time I run Bitbake here to build it, I'm committing to this repository. So what I have done here right now, actually before the presentation, I have done two commits, two builds, one initial build and one additional build with netcat inside of it. So I should have here two commits in this repo. I can basically show here the log. So this is the log with the two commits, and I can show the difference between these two comments. So this is what changed in this repository between these two commits, right? We can see all the files, the changed files and the added files. We can see here that I added a few files to this commit, the netcat files. We can also see that this is the hash of the first commit. We can also see that in my device, I'm running this one, right? So I'm running this one. So what I want to do now is to update to the new version. What I need to do, the first thing I need to do is start a web server. So I'm going to use Python here to start a small web server here that will serve the objects of this repo to my device. I'm connected to my device via local network. Then here on the device, I will add my host machine as a remote. So now my machine is a remote. I'm calling this remote Horizon. I can see the apps that I have in this remote. Sorry, because I'm not connected. Let me connect here the Ethernet cable. Let me see if I can ping my host machine. 225. Yes. So let me check the remote references. So here I'm sending requests to the HTTP server that is running in my host machine. You can see here the requests. And I can pull the objects from this remote, OS3 pull. This is the remote, and this is the branch. So I want to pull all of the objects from this branch of this remote. It should pull a few objects, 18 objects, fetch it. And now we can see the two commits. So I pulled everything, all of the objects, including the commits. So I can see here the two commits, right? And I can basically deploy the last one. So basically what I'm doing here now is an update. So if I deploy this one in my device, I'm gonna update the device. That's what I'm gonna do right now. So I'm gonna run OS3 admin deploy. I want to deploy what I have in the top of this branch, the last commit from this branch. So basically here is to create another checkout of the file system. It is merging the changes that I have done in my /etc to this new deployment. It is changing the boot configuration, and now it is ready to be booted. If I run here the admin status command, I can see that I'm running from this deployment, and this one is pending. I have just done a deployment of this one, and if I reboot right now, I'm gonna boot from this one. So if I do a reboot right now, I'm gonna boot from this new one, and then I'm gonna have the changes in this file system. So we have seen it's very fast because it will only download the changed objects, right? Again, security, you build on top of that. So to finish my presentation, OS3 is a very nice technology, but adds some complexity. There are a few trade-offs, right? It will add some complexity to the system. Of course, you just need to design having this complexity or the requirements in mind, right? So having everything /user, building a kind of immutable system, configuration file in /etc, data in /user. So you need to comply to those requirements. Of course, you just have one partition with one repository. So if you have problems there, you will not boot. So if that's a problem for you, you're going to have to design a kind of recovery partition where you can pull, for example, corrupted objects from a remote. I don't know. But you're going to have to think about that if like hardware problems is a problem for you, right? If your OS2 repo is corrupted, you may have problems. There is not much security design. As I mentioned, if you want security, you need to design something on top of OS3. And the rollback logic for the update system is also not part of OS3. So you need to design also this part if you want, right? There is a nice integration, for example, with U-boot that we use in Horizon Core. But the logic, you are going to implement the logic, not OS3. So those are a few trade-offs or things that you need to think about if you are working with OS3. Okay, those are a few links about OS3. I hope you all enjoyed this presentation. I hope it was a nice introduction to OS3, how it works. And feel free to get in touch with me. I don't see any questions right now in the chat. Let me see if we have any questions in the Slack channel. I'm not seeing, let me quickly go over this. I'm not seeing any questions also in the Slack channel. Feel free to get in touch with me, connect with me on Twitter or LinkedIn, send me a message. And again, I hope you enjoyed this presentation. And yeah, see you next time. Bye-bye.